We're now going to look at a specific type of trig equation, ones that are in this form. So some constant times sine x plus some constant times cos x is equal to c, and that means when c is not equal to 0. Because if it's equal to 0, well, then it's nice and easy. I can transform that into tan, because I can move the cos to the other side, divide by the cos. But if it's some other number, like this one here, I can't do it. Now, there's a couple of ways I can do this. The first way we're looking at is what's called the auxiliary angle method. And I can choose, do I turn this into a sine function or do I turn this into a cosine function? It basically gets these two pieces of trig and makes it into one trig function. Because remember, we know this result. Sine theta cos alpha plus cos theta sine alpha is the sine of theta plus alpha. And this I can turn it into that form because I do have something times cos, well in this case theta, plus something times the sine of theta. So it is in that form. So I've got 4 sine theta plus 3 cos theta. I've just rearranged it so I've got it in the form something sine theta plus something cos theta there. So it makes it easier for my head. So cos alpha must be 4. Well, it can't be 4 because we know that the cosine has to be in between -1 and 1. But what I can think of it is, well, hang on, yeah, the cos result involves 4. So I'm going to make the adjacent side equal to 4. And similar with the sine one, the sine can't be 3, but I'll make the opposite side equal to 3. And I can do a little bit of Pythagoras and work out the hypotenuse is 5. So I'm now going to change this equation. Basically, I'm going to divide by 5 and multiply by 5. And then I've essentially got the same equation. But now I've got something that can be a trig ratio. So what I'm now saying is 5 times the sine of theta plus alpha is equal to 2. I've got that. And alpha is that angle over there I've drawn in the triangle. I just got to work out what that is. But what will happen with this? The hypotenuse will always become the coefficient of my new trig function that I'm creating. So the hypotenuse will always be it. So 5 is going to be that number. Divide both sides by 5. I can work out what alpha is. It'll be whatever the inverse tan of 3/4 is. 36 degrees, 52 approximately. So back over here, I just solve a very simple trig equation. It's just the sine of something is equal to 2/5. Now it's in quadrants 1 and 2. The acute angle I will work out. So the sine of this acute angle, I can't call it alpha this because I've already used alpha. So I'll just call it beta. That's going to be 23 degrees 35. So theta plus 36.52, the alpha that I worked out, must be my two possibilities, 23.35 or 156.25. Move the 36.52 to the other side and I've got my two answers. However, remember, go and solve the initial problem. I want answers between 0 and 360. I've ended up with a negative 1317. That's okay, I'll just add 360 to that and that'll get into the required range of answers. So it becomes 119.33 and 346.43. I could have done exactly the same question, but what if I decided I want to make it a cosine function instead? Well, in that case, the pattern would go cos, cos, sine, sine. I can still do it exactly the same way. I'll draw up the triangle. In this case, the 3 is representing the adjacent side because I now want the 3 to be the cosine ratio. The 4 will be the adjacent side. The hypotenuse is still going to be 5. That's not going to change. But now I know it's going to be 5 times the cos of theta minus, because if it's not the sine, it's not the sine, alpha. Let's work out alpha. Alpha this time will be 53 degrees 8. Let's go and solve our trig one. The acute angle now is 66 degrees 25. So theta minus 53.8 is 66.25 or 293.35. I get the same two answers. Now you might be thinking, hey, that's a heck of a lot of working out here for that. The reality is I don't put a lot of those steps in. Here's an equation. How would I go and solve it? I'm looking at it, I'm going to decide, I'm going to turn this into a sine function or a cosine function. I make the decision. I'm going to go with sine. So I know it's going to be sine, cos, cos, sine. I still draw myself a triangle so I can see what's going on. But the adjacent side will be root 3 because that's representing the cosine. The opposite side, I'm not going to worry about the negative. That's just 1. Hypotenuse is 2. So now I know it's just 2 sine x minus pi on 6 is equal to 1. Because I must have gone sine of x minus alpha. which in this case is pi on 6. So sine x minus pi on 6 is a half. I'm in the first and second quadrants. There's my two possibilities, pi on 6, 5 pi on 6. Add pi on 6 to both sides, and I have my answer, pi on 3 and pi. And in fact, maybe, I mean, obviously I probably wouldn't write down the words quadrant 1 and quadrant 2 there. I probably wouldn't write that down either. Here's an HSC one from 2003. This time they sort of forced my hand. They told me, I want you to put it into this form. I want you to change it into a cosine function. Okay. Cosine function. Nicely, the coefficients for both of them are 1. So 1, 1, and root 2 is the hypotenuse. Oh well, that's an exact value there, 45 degrees. Bingo, there's my answer. I can write it down straight away. I know the coefficient of the trig function will be the hypotenuse, which is the square root of 2. I'm turning it into a cosine function, and it'll be x plus that angle that I just found over there. Now the advantage of doing that, why change it into one? Yes, for equations, but also for graphing as well. If you had to draw y equals cos x minus sine x, sure, you could draw both graphs and then start adding certain key points and do it that way. Or you could turn it into just a cosine curve. So you just have to draw that cosine curve. There's a bit of shifting happening, but it's still just a cosine curve. 2010. Again, they've forced my hand. I have to turn it into a cosine function, and they've told me that they want alpha to be an acute angle and r a positive number. But, oh, hang on a sec. 2 cos theta plus that. That's a little bit different. So what did we do that year? What I had to do was actually expand this out, the cos theta plus pi on 3 first. Now when I do that, fortunately it's a nice exact value. I can work out the cos of pi on 3, I could work out the sine of pi on 3, and I get that. Now I can group the cos and sine theta together, and I've got that situation where I've got a cos function and a sine function, which I can now pull together into one. They want it to be a cosine function. So cos, cos, sine, sine, that means 3 is going to represent my adjacent, root 3 is going to represent my opposite. Hypotenuse is root 12. Work out the alpha, it's an exact value as well, it works out to be pi on 6. So there we go. The hypotenuse was 2 root 3. I'm turning into a cosine function, and it will be theta plus, in this case, because if it's not the sine, it's not the sine. And the acute angle we just found out was pi on 6. Got our answer. Then last year, there's a beautiful multiple choice question. Real numbers A and B. A can't equal 0, B can't equal 0. We have to find alpha, beta, gamma and delta and R such that A cos x plus B sin x can be written in any of these 4 forms. Ooh. Okay. They then said, well, what's the value of alpha plus beta plus gamma plus delta? Wow. To make life easy for myself, I said, well, let's just assume A and B is 1. I don't have to worry about A and B. So now I'm saying, what is cos x plus sin x? Coefficients, so 1 and 1, which means the hypotenuse is root 2. I now know what R is straight away. R is root 2. But that's not what they're asking me. They want alpha plus beta plus gamma plus delta. Okay. I could now write it as root 2 sin x plus pi on 4. This acute angle would be pi on 4. So that's one of them. Okay. Alpha is pi on 4. But hang on a sec. That same angle alpha, instead of writing it as pi on 4, I could have written it as negative 7 pi on 4. So that now gives me what beta is. But if I turn it into a cosine function, then again the acute angle is pi on 4, but if it's not the sine, it's not the sine. So I could have written it as root 2 cos x minus pi on 4. So I now know what delta is. Delta must be pi on 4. And yet again, that pi on 4, remember I could write it as minus 7 pi on 4, which means I could write it as root 2 cos of x plus 7 pi on 4. I now know what gamma is. I can add the 4 together and I get the answer of 4 pi. 11B for that one.